comes to area, most things come to an array because like we have to classify what area is, and we talk about it by square centimeters. So for example, if you've got something 3 centimeters by 4 centimeters, like how do we define area? Well, really all we actually decided to do was say, hey, let's just make them into square centimeters. So what we meant by that is that 1 by 1 centimeter is 1 square centimeter. That's one of them. So really, if you think about like if you've got like 3 by 4 centimeters, you're going to have 12 in there because obviously this is your first centimeter line. And you got 4 of them here, 4, 8, 12, or you can look at it as you got 3 in here, 3, 6, 9, 12. So that whole thing will have 12 square centimeters. I do say square centimeters because if you say like 12 centimeters squared, are you thinking like it's 12 centimeters by 12 centimeters, like this? So it just creates a bit of ambiguity. So it's just important to make sure when we're going through looking at area, just a bit of terminology helps. So really we're talking about that. And how do you get this? Well, if you multiply 2 numbers, it's going to make this array because it's how many rows by how many columns, right? I mean, that's what multiplication is. I've got like 3 lots of 4. So it all comes back to that. So every formula comes back to a rectangle, or it's a manipulation of it, which is really length by width. Because if you think about it, if you times those 2 things, you're talking about how many squares you've got. Now, if I've got 3 by 4, I can make 12 squares out of that. And this is a really, like, it may sound really easy and like, oh, duh, but that's a really big concept right here, what we're talking about. So some of the formulas that you will need to know is area of a square. Well, obviously that's length by length because that's going to give you an array. Area of a triangle is half base times height. Parallelogram is base times height. Now, why does that work? I mean, if you look at a triangle, any triangle, it doesn't really matter. If you take its base, which is this one, and then you multiply it by its height. Now, its height is always perpendicular to the base. We define height is always perpendicular to a base. Now, if you go base times height, what that's going to give you is that's going to give you the area of this one, right? Like if you go base times height, it's going to give you the area of a rectangle because you've times them both together. I mean, that's what it does. So you're going to get that. But as you can see here, we actually, if you calculate that area, if you went base times height, you're going to get the whole area. But as you can see here, it actually only takes up half of the area. Hence, that's the formula for a triangle is half base times height. Because if you times base times height, it would give you the whole area of a rectangle, but it only takes up half of that. Parallelogram is, again, pretty easy as well. With a parallelogram, all we do there, they should be straight. They're parallel as well. With that, again, we just go base times height. If we do base times height, so if you think about the height here, the height, again, is perpendicular. When I'm saying perpendicular, it makes a right angle. Yep. So the height would be at right angles to the base. My pen, I know, is not the best, but I'm trying my best. Height. So if you go base times height, it's going to give you the area of this, right? So you'd go like perpendicular up here and this area because you've taken your base and you've multiplied it by the height. Now that would give you the square. Now hopefully what you can realize is that this bit, because it's a parallelogram, will fill in there. So that will actually be correct. So the area for a parallelogram is base times height. And that's the area for that one, which works really quite easily. Now, a kite as well, these are going to be all in your book, but I'm just going to go through them because I think they're really quite simple and I think they're really amazing, like how the formulas are made, and you'll recognize how it all comes back to a rectangle. If you got this, let's say you've got this length, and if you multiply it by this length, that's going to give you the area of a rectangle, right? Which is the width by the height, like you times 2 numbers together, that's where it comes from. Okay, again, if you take, let's just say you're taking this length here, which might be, the diagonal length or whatever you want to call it, or a cross. Obviously, let's just say if this was length A and that was length B, the area of this would equal, well, it would be half, because it takes up half the area, each little triangle of AB. So that's a kite, and that's how you can find out that one. Or you could call it a parallelogram on the side. So if you were given like the dimensions from there to there, or there to there, like if it was given across the diagonals, you would use this, half of AB. So they're all manipulated from here. There's not really a lot of difference. There is a little bit of a different one on this one here, which is slightly, a little bit different. Your trapezium, which we look at. This could be a rhombus as well, or a kite. It's the same formula. If you've got a trapezium, it's slightly different. There's a couple of ways I can show this. So this would be length A. Let's say this would be length B, and again we've got the height here, H. Now this is a bit different, and it does come for a few reasons. Now this actually, the formula for this one is half of A plus B times by height. Now if you just go like this, let me just show you something. If I doubled this, right? If I doubled this, so, and then I made another one, so I could put this across here, and then I need to pan across. So if I doubled this one here, right, this is one proof. There's a few proofs for the trapezium, and hopefully you guys remember this. So if I did this, now I've doubled it and flipped it. So this is the same edge as this edge. This edge is this edge here. So what I've done is I've doubled this, and then I've just gone flipped it and then shuffled it there. So you'd find that that would be the shape there. Now, so this is length B and this is length A, right? And if we called this side 2 and this side 1, that would be side 1 and that would be side 2. Now, I've done this. This actually is now, because that's the same angle as that one, this is a parallelogram, right? And now we know with parallelograms, the area for this is, because it's going back to this one, is just the base times the height. Now, what is the base in this? Well, the base for this is A plus B. So the base of this is A plus B multiplied by your height. However, I doubled this to get to a parallelogram. So it has to be half of that. Hence, that's the formula for the area. I think it's really nifty. Let's get into circles. Just a little bit of revision on circles. I think this will be a lot of prior knowledge for you guys. So really, a circle's pretty cool. I really like that. Now, the formula for a circle, I think, is just absolutely awesome. Like, I think it's really cool. So if you just, cut all this up into tiny, 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 tiny little bits, right? You get the idea. Let's just look at the first half, okay? This first half. If I cut those up into really small bits, and this is the radius, right? And then I stuck them together, right? So it would be kind of like this. Like all these little edges, right, would be like there, and these would be coming down and up and down and up and down and up, down and up. So you can get the idea what I'm doing here, right? But I'm saying they're really small, like they're infinitely small, because you'll be going, oh, well, obviously they'll be rounded on the edge. Yes, they would be. But I mean, if you cut them super thin, they'll be pretty much straight, right? So what we can do here, that would be the first half, right? So what length is this? Well, if you think about what the length of this is, we can figure what this out is. This is half of the circumference, right? Now, we know the circumference of a circle is 2 pi r, because remember, we talked about it last lesson, that pi is a ratio of the diameter. The diameter times pi will get you the full way around. So obviously it's 2 radiuses. Now, we've only gone halfway. So what's the rate? The circumference of this is, well, half of 2 pi r. And half and 2 would cancel each other out, right? Because half times 2 is 1. So the circumference of that is just pi r. So the length of this is pi r. Now, this second half, now remember I only did one half of the circle. This second half, what I'm going to do is I'm going to also cut it into really small bits, but I'm going to glue it in this way. So these bits will all be the bottom half, right? So, you've got the bottom half are all these bits that I've put in here. Like that's all coming from here. That would all be these bits down here, right? So I'd cut them all up. They're these bits, okay? And the other bit's there. So the length of this is also pi r, right? That's also pi r. This is pi r too. So what's the height here? Well, the height here is the radius, because that's where I've cut it. So you can see, again, I've made a rectangle. So what's the formula for this? Well, it's pi r times r. And if we simplify that, it's pi r squared. So I made a circle into a rectangle and proved that the area of a circle is pi r squared. And that's why it is. And I think that's really neat. If you haven't seen that before, It's pretty sad. But I think it's absolutely awesome. And recognizing that all these come back to a rectangle, because really that's what area is. Area is just about, how many rows by columns of those square centimeters we have, and we just make everything into basically a rectangle, and all these formulas represent the shape, but they all come from a rectangle. And they're really nice. So the last one would be if you just had a part of a circle, obviously. So if you've got a part of a circle, well, let's just say, you've got this angle, you've got this circle. Well, if you've only got so many degrees of it, well, the area of a sector of it is going to be, well, however many degrees you've got over 360, because it's a fraction. How much I've got? That's 360 times by, well, the whole circle, pi r squared. And that's it, really. That's how you'll get the area of your sector. That's pretty much the whole subchapter there. The only other thing is, like, if you've got to go from, for example, you've got 1.2 centimeters squared and you want to convert that to millimeters squared, well, just how many, you times that by 10 normally, right? So just times it by 10. But because you're dealing with area and it's squared, you're going to square your conversion. So that would equal 120 millimeters squared. One other thing to note is yep, that's all right. No, we don't need to note that. So that's it. An interesting thing is a hectare is a 10,000 meters squared. That's one other thing that sometimes comes up as well that you may find. So really it's about, you just convert anything. So if you want to go from meters squared to centimeters squared, that's why, you times it by 100 squared, centimeters squared to millimeters, 100 squared. If you want to go the other way, you just divide it by the normal thing, but it's power of 2. Same thing will happen with volume, except you'll do it to the power of 3. So that's it, those ones. Really, it's just going through some of these questions. Again, the hardest thing I think about this is where some people go wrong, is they forget that base is perpendicular to the height. Sorry, the height is perpendicular to base. So for example, I could give you a triangle, like a tricky one, and I might say, hey guys, calculate the area of this triangle. Now, there are other formulas you can use later on, like Heron's formula. You can also use a bit of sine to get the perpendicular height. But let's just say I said this is 5, this is 6, and then I said, this is a right angle, right? And this was like 8. Now, how would you find the height of this triangle? Well, what you've got to recognize is that it's half base times height. And remember, the height is perpendicular. So it's actually going to be this times this, because that could be a height and that could be a base, or that could be a base and that could be a height. So I'll just rotate it slightly using 8. So that'd be 8, that'd be 5, and that'd be 6. So then you'll find it'll be a bit easier. This probably isn't correct, by the way. It can't be correct. Let me just do one that would be correct. 3, 4, 5. Sorry, that's better. So that would be 3, that would be 4, no, that would be 5, sorry. That would be 3, and that would be 4. So then you'd have to go 3 by 4 times a half. Note, it needs to be perpendicular, okay? So sometimes you get some really weird ones, like you might get some triangles that look, like this, and it might have like the height here is like 3, you might have like 8 there, and then you might have, like maybe 9 here. Now, you're going to go 8 by 3 times a half. You're not going to go 9 by 3 because it's perpendicular, right? So the height is always perpendicular base. Now, I mean, just because I haven't drawn that typically like this doesn't mean it can't be the base. So just think of rotations when you guys are dealing with these things, because they can get a little bit tricky when you sort of start dealing with those. But that's the subchapter there. Then really, it might become like you've got to look at composite shapes as well. That will be the next one. So composite shapes are just going to be parts of the shape added together. So, you might have, for example, just moving into the next subchapter, if you've got like, a rectangle, right, and you want to find out the area of that, that's a really bad rectangle. And that is shocking. Let me draw this again. Okay, if you've got a rectangle, and you might have like a triangle on the top, right? And you might be like, oh, that's a really bad triangle. What's the area of this? Well, there's a few things you need to know. Let's just say, you're told the overall length of this is 10. You know that this length here is 8, and you got 3. Well, this is quite easy. You just need to break it up into shapes, right? So you can see that this is 8 by 3, 8, 16, 24. The height of this, because that's overall 10, obviously would be 2, right? This would be 2, and the base is 3. 2 by 3 is 6, and half of that is 3. So the overall total length of this would be 27 squared, units squared. So you'd be like units squared. That's how you'd answer it, because I gave no measurements. So sometimes we don't actually need to give measurements. You can do things without it. You might have some other shapes, you know, like with a rectangle with a bit of a triangle taken out. So you would obviously calculate the whole rectangle and then just minus that part. Sometimes you add them on, sometimes you take them out. It's not too bad. Another typical kind of shape would be, you know, like a rectangle with a semicircle on it. Again, then you're going to do like 180 degrees or half the area of the circle plus, you know, the rectangle as well. So you'd figure that one out, like it might be a basketball, you know, key ring or something like that, where you might be like, okay, you know, what's the, you know, where they've got all the, you know, when you're playing basketball, you know what I mean? You've got the basketball court here, and they might be like asking you, okay, what's the area of the key, including, you know, this area here, when you're playing basketball. So you'd need to figure that out too. So composite shapes are just really adding and subtracting different ones. You know, you could have a rectangle with a triangle taken out, and might say, you know, figure out the area that's shaded. Again, you're going to do the whole rectangle minus the area of this. So really, it shouldn't be too bad. So that's pretty much most of the instruction I'm going to give you guys for it, for both these subchapters. Just be mindful of some things, like if you've got in composite shapes, you know, you might have something like this, and just use your common sense. Like if I had this and all these are the same radiuses, well, that's just a square plus a full circle, because, sorry, plus 2 full circles, because that would make one whole circle, right? So just try and use a bit of common sense and see where the shape is for it. And then, yeah, you should be able to calculate that one as well. So that's pretty much it on, well, that is it on those 2 subchapters on area and composite shapes. And hopefully that gives you a bit of an insight into where we're going. And good luck. Yell out if you need a hand, and that's area for you, and it all comes back to a rectangle. And a square is a special type of rectangle too, so that's obviously the length times the length.